extrude this front face over a distance of 50 millimeters as well. And I'll rotate this face here. Easiest way for me to do that is by highlighting it and under Model, clicking the Rotate command. Now it gives me this little arrow to ask me around which axis to rotate. I want to choose this axis here and rotate it 15 degrees downward. Right, so this is now a massive solid, so that it's not hollow yet. The way to do that, to make this hollow, is by using the shell command. You can find it in the Home tab of the ribbon, or in the Solid tab, or the Sheet Metal tab. I mean, there's loads of places to find it. Now that we're in the Sheet Metal tab, you can find it here under Edit. So it asks me to select a 3D solid, so I will select this solid here. And then it asks me faces to remove. So basically, which part of or which side of my solid will be open. And in this case, I want this bottom part to be open. So I will select this face to remove. And all the others will not be removed. So if I now press Enter, first I have to still define a thickness. I will choose 10 millimeters. Sorry, 2 millimeters. And press Enter twice. Actually, you need to press Enter twice to exit the command. And now you'll see that everything has been hollowed out. The bottom side is gone, and everything is 2 millimeters thick. Now, before I turn this into a sheet metal object, I will first make some final changes. Namely, I will create a hole in this face here. So I will do that by first creating an offset. So if I use offset on a solid face, it will take the outer boundary of this face, make a polyline out of it, and offset this. So under Draw, Offset, it's a bit hard to see. I will choose an offset of 10 millimeters. Now I will select this polyline that was created. And using the solid extrude command, I will extrude a hole into my solid. Now I need to make sure that when choosing the depth of my extrusion, that I don't go too deep, because I am actually creating a hole here in the back of the solid, which I don't want. So I need to go deep enough that I'm going through this face, but not too deep that I'm not going through here. So something in between here, like 50 millimeters or something, should be fine. And I have my extrusion here. Okay, so now this is still currently a solid without any sheet metal intelligence or features. So I will turn this into a sheet metal object using the Convert to Sheet Metal functionality. So I'll hit this button here, select my solid, and press Enter. As you can see now, it's all turned blue because these are all now flanges, and they are colored blue by default for sheet metal. Now, before I continue turning this into a proper sheet metal object, I will need to make some small changes or some fixes. For example, creating reliefs. So, I can create reliefs for my entity automatically. So I will just choose entire model, and it will create for me these little holes, where otherwise there would be a sort of clash between two adjoining entities. So some material is taken away to avoid these kind of clashes. All right. Now, to be able to unfold this, we need to define bends and junctions. So the software needs to know where it's going to be bent and where parts of a sheet metal are going to come together in a junction. And I will do this semi-automatically. Well, actually, I'll start off by doing it manually. So I will choose the junction tool here. And I will select some hard edges to make junctions. So I'm just picking them individually here. And as you can see, the junctions are colored in orange, which again is a color based on these color features. So I will take these edges here as well. And escape. Now the other edges, the ones I didn't indicate as junctions, those will become bends. So next to the junction command, there's also the bend command. I can either, again, go manually through all of these edges here, or I can just press enter to automatically assign bend to the rest of the model. So everywhere that's not a junction yet, or that nothing else has been assigned, it will create bends for me. So all these yellow things are bends. So this is where the sheet metal will be bent into shape. All right, so let's take a look at what this looks like if we unfold this. So again, just highlighting the face here and choosing unfold body. So this seems to be okay, although there is quite a lot of waste of material. For instance, this window here, these parts might be unusable. It might also be too large for my my bending machine or my cutting machine. So I will try to reconfigure the bends and junctions so that it's a more efficient use of material. To do that, I will start off by turning these junctions into bends. By the way, before I do that, I just want to make sure to check my mechanical browser and see if everything is okay here. So I can see currently that all my flanges and bends and junctions, they're all colored in white, which is good. However, it might occur that it turns red, and that means that there's something wrong with it. For example, a sort of clash between parts. So if it turns red, you need to manually fix some things. Now, I know that for this exercise, in older versions of BricsCAD, there might be a sort of error or warning here that you need to fix. However, I'm running the v21.1.7, which is one of the latest versions, and there these errors are fixed automatically for me, so I don't need to do anything. Okay, so I'm going to turn some of these junctions into bends. So I will take this bend command here and choose this junction and this junction. Like this. Now, if I would now try to unfold this body, it probably wouldn't work. Let me try. So you can see it turns red, and there's just, it's not physically possible to make an unfolded model of this. So I need to create some splits. I'm going to split this flange here, this flange with the window, into 4 smaller parts by adding little break lines in the corners here, or split lines in the corner. So I can either do this manually, so clicking a point here, and it will create this split for me automatically. Or I can use the split propagate command, smart split propagate, where it asks me to choose a location, for example here, and it will automatically find similar locations where it can create the split. So this is actually based on a propagate command in the BIM workspace that we will cover next week. But it's a sort of smart suggestion tool where you can apply the same logic. So I will accept this suggestion. So these 4 splits here, I'll press enter. And now I will try again to split. Sorry, to unfold. Before I do that, I will just check in my mechanical browser. I now have 2 bodies, so I can see I have 2 separate bodies because of these junctions and these splits. This has now become one separate body and this is a separate body. So this means I will also have to unfold twice, once for this body here, and a second time for this body here. So that might already be a more efficient use of space or use of material in the case of this sheet metal object here. Okay, that was the second exercise. So we have seen two exercises, both on modeling with sheet metal. I suggest we now go to the breakout rooms and you have some time to try this for yourselves.